Welcome to Train Signal. You are watching Storage Capacity Management. So the first thing we're going to talk about in this lesson is using and managing VAAI. VAAI stands for VMware vSphere Storage APIs Array Integration. So big long name, but as the name kind of suggests, it's a set of APIs and protocol interfaces. The idea is it allows vSphere to better integrate with your storage systems, and the reason we would want to do that is to offload things for better performance. There's a lot of things that you may not be aware that the vSphere host does. Great example, creating a VM, you want to do eager 0 thick for the VMDK because you have to thick provision it, and let's say it's, I don't know, 100 gig disk. When you do that, the vSphere host actually sends 100 gigs worth of zeros up to the storage array. So he's basically for 100 gig going nothing, 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 nothing. And like it or not, that's 100 gig that flows across your storage fabric. And it also takes CPU away from the vSphere host. Not a lot, of course, but it adds some. And if you start doing things like spinning up VDI clients or big copies, big moves, it really does start to add up. And more importantly, it can take a long time. It takes a long time to do that provisioning. And so we could do that better. And now we do that with VAAI. Two main functions of it. One is hardware acceleration, and the other is kind of what I'd call thin provisioning. And by that I mean it lets us do things like space reclamation against the array. So if we expand out disks and we use more space on the array, then we delete some data, we can actually do things like pull that space back. But those are the two major items. The gotcha is it requires support by your array. Now, most modern arrays, and by modern, well, I won't say modern because modern may be, in the last 5 years. Most current arrays support VAAI. Even ones that came out before have usually had software updates to allow them for integration. But, your mileage may vary, and my favorite answer to everything is it kind of depends. So check with your array vendor, see if you need to do a software update or something like that. Cool thing is, it can accelerate many common tasks, as well as reduce storage fabric utilization. Things like migrating virtual machines with storage vMotion. So if you want to storage vMotion a VM from one data store to another, the caveat here, it has to be on the same array. There's no cross-array VAI yet. But if it's on the same one, your vSphere host can just say, hey, Mr. Array, I want you to move those blocks or files from here to here and let me know when you're done. And it'll run off and it'll do that. And it's pretty nice because A, it's quicker, and B, you don't see that data being pulled from the data store and then pushed back to the other data store. So it greatly reduces load on your storage fabric. Deploying virtual machines from templates, this is basically a copy, right? If you deploy from a template, it does a clone. Well, the vSphere host doesn't need to do that. It can just tell the array, hey, go do me a favor and make a copy of that over there, just kind of like we did with the storage vMotion, and it makes it much quicker. One thing that I did a post on my blog, because again, I use Synology NAS boxes within my home lab, and on some of their models, they now support VAAI on the iSCSI protocol. And I showed what the fabric utilization and the time reduction was when you did with VAI against doing it, in software the old-fashioned way. And it's a major reduction. Cloning virtual machines, cloning templates, anything like that, again, we're just moving bits around. VMFS clustered locking and metadata operations. So this is another thing. This is called Atomic Test and Set, ATS, back in the day, a couple of years ago, I guess you'd say. And actually, in previous lesson where we talked about SCSI reservations, we used to have a problem where we wouldn't put a lot of VMs on a data store. We used to actually, at Vero, recommend somewhere around 15 to 20. Now, if your array supports VAI and ATS, you can do, 150, 200 VDI clients or VDI VMs on a single data store. And the reason being is that we can now just lock certain aspects of the LUN or certain pieces and not the whole thing when we do metadata updates. So it makes it much more efficient, and we don't run into those problems like we used to. That's one of my favorite things that VAI does, and it allows us to have much denser consolidation within a data store itself, which is becoming much more important as disks get larger. Now we're doing disk pools. We're not dedicating disks as much as we used to because the math wouldn't work out. I don't want to dedicate a bunch of 900 gig disks and only be able to put 15 VMs on it. It just doesn't work that well. Writes to thin provisioned and thick virtual disks are accelerated. Creating fault-tolerant virtual machines. This is kind of an odd one. I actually took this out of VMware's documentation for this, and one of the reasons is I like to kind of combine aspects of things. And I think you'll see this a lot within the exams, because like I've said, the labs aren't like go do this. It's hey, make this happen, or here's a couple things you need to get done. So why would I say that it helps creating fault-tolerant virtual machines, especially when we haven't got to the fault-tolerant lesson yet? But I'll give you a little bit of a spoiler alert. You have to have eager zero thick disks. And if you say, hey, I want to do FT on a VM and it's thin provisioned, it'll say, do you want me to convert this? And if you say yes, and it's a big VM, that can take a while, so this speeds that up. Creating and cloning thick disks on NFS data stores. So this one is kind of separate, and the reason I put it in here is originally VAI was block only, iSCSI and fiber channel. Hey, that's great. What about those of us who use NFS? I'm a big fan of NFS for vSphere data stores. Now you can do it. It just requires a software plugin that you install, and then it just integrates. Some of this stuff isn't quite built into the pure NFS spec, so we have to do things a little bit differently. But it now supports it on creating and cloning thick disks on NFS data stores. Couple caveats. So here's a couple of gotchas. Source VMDK type is eager zero thick, and the destination VMDK type is thin. So basically, if you're doing some copies and things like that, if I'm copying a thick template and I'm going to convert it to thin, I can't use VAI, because I can't tell the array, hey man, go copy this over there. He's not smart enough to go, hey, copy this, and by the way, also thin it at the same time. That's putting too much on the array. It's not that intelligent yet. The VMFS data store has multiple LUNs or extents spread across different arrays. Can't do that. Like I said, we don't have cross-array VAI yet, so if things are spread around, that's a gotcha. And if I ever find you and find out you're doing VMFS data stores and you're doing multiple LUNs or extents spread across multiple arrays, you and I are going to have a very uncomfortable conversation. And we'll be like, well, why are you doing this? But just a heads up that you can't do that. Source and destination VMFS volumes need to be same block size. This is an important one. So if you remember when Vsphare 5, when it came out, one of the cool things was VMFS version 5. One of the cool things of VMFS version 5 was we can now do everything as 1 meg block size. We don't have to choose that block size when we format it. Now, you can do a live update from a VMFS 3 data store to 5, but it doesn't redo the block size. So if you create a new one and it's a 1 meg block size VMFS 5, and you have an older one with, say, an 8 meg block size that you migrated up from VMFS 3, you can't do VAI accelerated copies or moves between those two. So that is the only reason that I normally tell people that if you want to do that, you got to rebuild those old data stores. Other than that, the block size difference isn't a big deal. But if you think, hey, I want to be able to move things and do this, or maybe it's VDI data store or something that you're going to be doing a lot of moves or creations on, you may want to rebuild those data stores, reformat them with the 1 meg block size, and therefore you get the acceleration between those. Cloning a virtual machine that has snapshots, or doing a vReplica or recompose. The problem here is that you have to do a snapshot consolidation, and the array can't do that. He's not smart enough. I'm sure within a couple of years, arrays will become much more VMware aware or integrated or intelligent and allow it to do things like this. But today, your arrays don't know about consolidating snapshots, so you can't do that. So if you're cloning machine, snaps, nope, not going to be VAI accelerated. Mentioned it a minute ago, it now supports NFS via plugins, requires Vsphare 5, and a software plugin from your array vendor. So EMC has one, NetApp has one, there's several others for the different arrays that do NFS, so you just got to do that. So now let's jump to the lab. In this lab, we will show status of VAI support. There's not a whole lot to do, honestly. I'm just going to show you how you can kind of run some commands and make sure that it sees VAI and see exactly what we call primitives, those different functions, which ones are enabled. So with that, let's go ahead and let's jump in the lab. Okay, so here we are in my lab, a couple of vSphere hosts here, and what we want to do is see what's going on with VAAI. So let me pick one of my hosts. I'll pick Optimus here. You'll notice that I'm a big Transformers fan. Got all my stuff named after that. Well, most of it anyway. So what we want to do is you want to pick a host. I'll start at the beginning. And you want to go to the Configuration tab. Then you want to scroll down, if you need to, because of my resolution, to Advanced Settings under Software. Make sure you're under Software, Advanced Settings. And then we look in two places. So the first one is under Data Mover, right here. And you want to see one. So we've got Data Mover Hardware Accelerated Init, basically VMFS data initialization. And then Data Mover Hardware Accelerated Move, so VMFS movement. If you have those for one, that's how you enable that for, say, writing out thick provision disks or copying data from one place to another using VAAI. If for any reason you need to disable this, you can come in here and set these to 0. The third one is down here. You go down to VMFS3. And the one we're looking for is VMFS3 Hardware Accelerated Locking. So this is our atomic test and set. Again, it's set to 1. If you ever need to turn it off, you can set it to 0. You can also do this via the command line. So let me see here. It's using the ESXCLI system command. And I think, yep, there it is. So I already typed this in because it's a rather long command last time I was in here. So it's ESXCLI system settings advanced, just like we went into the advanced settings a minute ago. List. Now if you just do this, it's going to dump out all of them. But if you want to get specific, you say -O for option, data mover, just like we were in the options a minute ago. We were in the data mover subsection, and then hardware accelerated move, or whichever one you wanted to check. And if we hit enter, it'll tell us that it is currently set to 1. So that's an easy way. I guess you'd call that an easy way. I prefer doing that through the GUI, but that's a way you can do it from the CLI. If you want to see if VAI is being used on a specific LUN, you can do ESXCLI. I believe it's storage. Sometimes I'll walk through this. It's core storage. Storage device, VAI status get. And if you hit enter, it will show you that it's supported for some of my LUNs. Some of these up here are not. So it'll show ATS, which is atomic test and set, clone, 0, and delete. And so on these, they are all supported. So that's how you can check and see if VAI is being used. So it's a pretty simple little tool. I don't think there's much else you can do here as far as status yet. You just do get. You can do, yeah, I didn't think so. So there's not a whole lot else you can do there. You can't really set anything or do anything like that. But that's it for this lab. I mean, there's not a whole lot you need to do other than making sure your array is configured to support it. If you're doing this against NFS, make sure your plugins are installed, and then just confirm your settings and confirm it's being detected correctly. So with that, let's jump back to the slide deck. Next, we'll talk about administering profile-based storage. A word of caution, I believe in the blueprint, in some places you'll see this as profile-driven storage. I'll use the term profile-based, but it's the same thing. The idea is it lets you define certain characteristics for storage. Can be anything. Replicated tier 1 SATA SAS. vSphere doesn't check. And the idea is, think about these as tags. If you've ever seen anything used for tagging, this is the idea. You can do this one of two ways. There's user-defined characteristics or tags, and then there's tags that you actually pull off the storage array. So if you don't like what your storage array says, or it doesn't support it, or whatever, you can always create your own. Name them whatever you want. vSphere doesn't know if you're lying and say, hey, this is replicated when it's not. That's completely up to you. But then you can set it so that you say, hey, this VM needs to be on replicated storage, and if it's not, it'll warn you about those things. As I just mentioned, storage vendors can also pass characteristic information to vSphere. This is called VASA. It's kind of limited in functionality, mainly because there's not a lot of things that can be passed. I see it as very 1.0, as I say. It's going to get better, but it's okay, but it's not great. But I see a lot of potential in what it can do. And again, I just mentioned VASA, VASA, vSphere Storage API's storage awareness. So it's trying to make vSphere aware of what type of underlying storage that there is. When you create VMs, you can specify which storage policy they should follow. So like I said, you can say, hey, this VM needs to be a replicated storage, and you can do a compliance check to see if it does. And if it doesn't, you can then know to remediate that. The problem is that there's no automatic remediation, so it's kind of up to you, but at least you'll be aware. So here's a diagram of storage profiles. So we could have something coming. This is a system capability coming from a storage vendor, another storage vendor. What I want you to understand is, you may have EMC or NetApp and EqualLogic, whatever, and you have multiple things with multiple capabilities all feeding in. And then you can create your own user-defined capabilities. Those are added into vCenter Server or show up in vCenter Server, and then you can kind of specify your policies from there. For the system capabilities, you'll need to install some software, again, from the vendor, so it knows how to query the storage array. Here's a diagram of virtual machine policies. So again, we've got our capabilities. And what I want you to understand is we can basically say, hey, this VM, we tag it with a certain profile, and we need to make sure it's compliant. So we could say, hey, this VM, let's say this is, replicated NetApp. We could say, okay, I want to give you a profile. It needs to be on NetApp, and it needs to be replicated. Is that compliant? Yes. We could do another one here. Is that compliant? Yes. But this one is not compliant. So we've dictated it needs to be on Tier 1 storage, but this profile has not been applied, and he is not compliant. And then you can check that right in vCenter, and it'll show up on the VM summary page. So now let's jump into the lab. Probably makes a little more sense when I show you the steps that we go through to actually create and do these. So in the lab, we'll first create some user-defined capabilities, enable profile-driven storage. So this is something that is kind of a gotcha for some people. You actually can set all this up and apply it, but you have to actually go click a button to enable it, so we'll do that. We'll assign some profiles to the data stores. We'll assign a VM a storage policy, and then we'll check the compliance of that VM. So let's go ahead and let's jump into the lab. Okay, here we are again in the lab. So what we want to do is take a look at profile-driven storage. So to start, let's go to Home, and actually let's first go to Storage Providers. So I talked a little bit about VASA, where you can actually pull information about the storage from the storage array. This is where you would do that. You would need to click Add and give it the vendor information for your array, a URL, login, and a password. I don't have a storage array in my lab for this functionality, but that's where you'd plug it in, and it's vendor specific anyway, so whatever I gave you probably wouldn't work for you. But the thing to understand is you punch it in here, you hit OK, and then you can do a refresh, or if you want to manually sync information from the array, you would click that. So if you ever needed to pull that information, you wanted to kick off a job manually, you just come in here and click it. Click your provider, click sync, and have it sync all that information. So that's useful if for some reason it's not pulling that and you want to double check it. So that'll pull in system-defined capabilities. To do our own user-defined, we go back to Home to VM Storage Profiles. Then we see here that I really don't have anything. So one thing is there's some items at the top. First, what we want to do is manage capabilities. So this is where you add yours. If there were any from the array using VASA, they would show up here as well. But I don't have any, so we don't have any. To create my own, I click Add, and then you basically just create a capability, kind of again like a tag. So you could say gold, you could say silver, and you could say bronze. And of course you can put a description down at the bottom if you want to do that. Let's see. One other thing. This is one of the issues I have with profile-driven storage. So what I'd normally want to do is probably add something like gold and replicated and silver and non-replicated and things like that and have multiple capabilities or multiple tags. The problem I run into is that you can only assign one capability to a data store. I think we're going to see that expand later, but that's kind of an issue, and I'll show you why it's an issue here in a minute. But for now, let's just do gold, silver, and bronze. So we'll go ahead and create those. And the next thing we want to create is a VM storage profile. So you can do it here, or you can do it here. Click that, and I'll create one for Tier 1. And again, you have your description. So we'll click Next, and then you pick your capabilities. So this is the profile we will assign to a VM's VMDKs and see if it's compliant. Well, if I can only assign gold or silver or bronze to a data store, what happens if I select 2? What happens if I selected, gold and replicated? Well, if the data store had one of those capabilities, you would be compliant. So if it was on a gold or it was on a replicated, but you can't combine them. So a lot of times what we see people do is it's kind of a one-to-one relationship between the profile and the capability. That's what I don't like. I think we're going to see that improved, but we're not there yet. So this will be Tier 2, and we'll make that guy silver. And we see those created. Then you need to enable it. So this is something that people forget to do, so we'll come up here and click Enable. So it's going to tell you, here's your cluster, here's your data center, all host license. Now, as of now, I think last time I checked, you had to have Enterprise Plus licensing for this. VMware sometimes move things between license levels, but the idea is you want to make sure they're licensed. One other little quirk I noticed was I had one of my hosts in my cluster powered down with DPM, and it would not let me enable this until I powered that host up. He talked to vCenter, and then we enabled it across the board. So if it won't let you do it, and it's giving you a message down here about an unknown licensing status, that would be why. So you want to click this and then enable. And it'll go off, and it'll enable storage profile status. And you click close. Then, let's see, we've done that. We've enabled it. Now we want to go and assign capabilities to data stores. So you can go back to Home or click at the top and go to your data store inventory. And I'll click Data Store 1. I'll right-click him, and I will assign user-defined storage capabilities. And you can pick and choose. Notice you only get to choose one. Now you can come here and create new ones right here. If you want to, maybe you forgot. But in the end, you can only assign one. So we'll give him gold. And for Data Store 2, I will assign him silver. And if you notice, when we come over here, like, let's see, yep, it shows it here on his summary page that he is silver, and it also showed it back on the configuration page. If I do let's see, it should, oh, there it is, refresh. It'll show silver, so you can see that there. So we'll go back, and now that we've assigned that, let's go look at our VMs. So I'm going to choose my little media box here. I will say Edit Settings, and you go to the Profiles tab. In the Profiles tab, VM Storage Profiles, and you select one. If this is grayed out, it means you forgot to enable profile-driven storage back on that screen where we check the license and all that. So go back and do that. So you can basically select one and propagate to all disks. I only have one disk, so it's not that exciting. Or you can go on a disk-by-disk basis and go and select the ones you want. Up to you. I will hit OK. It will confirm the setting, and we'll look here. Give it a second, and then we can do a refresh to check compliance. And it says, hey, this guy's compliant as of this day and time. We're all good and happy. Let's say that we come back and we decide, this guy really doesn't need to be on that. So let's change him to Tier 2. Propagate and hit OK. Let the change take effect. Do a refresh. And it says, whoa, he's not compliant. So we can click that, and it's going to say a capability mismatch, which is pretty simple. That's kind of the point of this. But it's going to show that it's not correct, and then we can go look and see what he needs. So here's my review of this. For one, on the exam, know how to do this. Know the steps. Again, the thing most people forget is actually enabling it, so make sure you do that. And then know how to use it. For real world, I'm not seeing a lot of people use this for the reasons that I showed you. I mean, it's kind of great if you do gold, silver, bronze, but yeah, I mean, it's not perfect. But, I'm a lot more interested when we can do multiple capabilities on a data store. VOS is the same way. You only pull back one capability off the array, not multiple. So if it's, fast SSD and it's replicated, you can only assign it one capability. So Not as usable as we'd like, but it is what it is. So that's it for the lab. Let's jump back over to the slide deck. So now let's talk a little bit about VMFS signatures and resignaturing. Every VMFS volume has a signature. It's a unique identifier. And there's an example of one right there. And the idea is two data stores with the same signature is generally not a good idea. Reason being is vSphere doesn't track things by the data store name. Names are too simple, they're too easy to duplicate, and it's a common problem. So you don't want to have two with the same signature, and that's how we kind of keep these things unique. Sometimes we see the same signature if we do something like clone a LUN, or take a snapshot of it, and then present that clone or that snap to your vSphere host. They're going to look at it, and if they automatically mounted it, then it would come in and you'd have duplicate VMs and all kind of stuff like that. So it's generally not wanted. But there are times when that is the case. Maybe I took a snap, I deleted a VM off of the production data store, and now I want to pull that VM off a snap. So when you add a data store, there is a check to see if it's a known data store. It looks at those UUIDs. And if it sees one that it already knows about, it'll say, whoa, I'm not going to automatically mount this. It's going to ask you, do you want to resignature this or not? And so what you do is when you go through the add storage wizard like you normally would to add a new LUN, you'll go to the storage, you'll say add, you'll say disk/LUN. Here's the LUNs. It'll present those to you that it sees. And if you pick one and it recognizes it, it'll say, do you want me to format it, resignature it, just go ahead and mount it? What do you want me to do? And normally you would go ahead and tell it to resignature that guy, mount it, bring it in, and pull the VMs off of it. This used to be done all via command line interface, and you still can using the ESX CLI commands, but I'm going to use the GUI, especially if I'm in the middle of a VCAP exam and time is of the essence. I would just do everything through the add storage wizard, and I recommend you do too. Let's talk a little bit about some of the storage CLI commands. We'll hit some of these now and some of them through the course, but I want to kind of put a little bit of brackets around what we're going to talk about. ESX CLI I've already mentioned several times so far. We'll keep hearing about this and using this throughout the course. It's kind of your Swiss Army knife of commands. It's kind of what VMware is doing to centralize all those commands that we used to have. There's VMKFS Tools, which is for the VMFS file system. We'll talk about that in detail, but it allows you to do file system management. There's svmotion, which is a storage vMotion command line interface on the VMA. I don't use this too much. I'll show it to you in a minute in the lab, but again, if I'm on VCAP time, I'm going to right-click and choose Migrate on a VM. I'm not going to go do this via the command line since it's kind of slower, especially as I got to trudge through all the options for that guy. vSCSI Stats, this is a really cool tool. Pulls back a lot of interesting disk information. If you want to know how much sequential versus random I/O that it sees, this is how you can pull that. We're going to talk about that command in a later lesson on storage performance, but it's pretty interesting. And then kind of the general purpose performance monitoring command line tool is ESX Top. We'll hit that again through several lessons. It'll show you a lot of information similar to what you see in the vCenter performance charts, but often in a little different format. But it's really handy for tracking down any performance problems. It's obvious. Choice of which tool you use depends on what you're doing, and as we go through, you'll see the use cases for each of these. VMKFS Tools. Now it's a command available in the shell for managing VMFS file system. You can use it to create file systems, manage file systems, and even create RDMs. You run it directly on a host or via the VMA, which is the vSphere Management Assistant that we'll talk about in a later lesson. But it's a pretty handy tool, and some things you can do there. It's kind of hard to do, those functions anywhere else. Let's take a look at some of these tools. Some of them we're going to go in a little bit detail, some we're not. Some of these I didn't even mention, but I'll just show you each of these and just kind of get an idea of what we're looking at. So with that, let's go ahead and jump on out over to the lab. So let's go ahead and open PuTTY. First one we'll do is go straight to a host. VMKFS Tools, and you're going to get a million options. So if you look through this, you can do a lot of things. So you can even do stuff against virtual disks. I think I forgot to mention that a minute ago. So you can do things against VMKFS or VMFS volumes. Like right here, you can create a file system, VMFS3 or 5. You specify block size. You know, if you want to span one, if you want to grow one, you want to do a query, you know, anything like that. And for virtual disk, you can do things again like create them, eager 0 thick, or, you know, write zeros, what kind of disk format, what kind of adapter type, all of that right here. So again, generally on a day-to-day function, there's a lot of this that you're not going to use, but you can pull some information, and you can also do things like, you know, create and extend right here from the command line. So very useful, very interesting. How much you use it just kind of depends, but it's not a complex command. Just understand what you're doing here. So if you, as they say on the VCAP blueprint, it's not about how you do something, it's about what you do. And if I was going to create a new file system, I'm going to do it through the GUI. Same thing for a virtual disk, but just keep in mind that you've got the option. So now let me go to the VMA. VI admin. Okay. So let's see. One thing we want to look at is, I forgot one on the host. df. If you've ever used Unix, there's a df command for disk space free. And it'll show you on your each data stores how much space you have free on each one. If you just do df, it's going to give it to you in bytes, which is, you know, a lot of math, or at least a lot of trying to figure out and convert that into gigs or terabytes. If you do -H, you'll get this in human readable format, as it says, size in terabytes, used gigs, things like that. The other one from df is vdf. So if we look at that, it's basically going to show us some information on vSphere itself, kind of like you know, tar disks information, some of the different other files and volumes that it has. With ESXi, you know, it's not as big a deal. It shows your root volume, etc, your temp, things like that. But if you do want to check space on the vSphere host for some reason, maybe for patching, you know, how much patch space do I have, you would use VDF-H. If you want to see on data stores, it's df-H. So now let's go back here to VIFS. VIFS, that's not going to work because I need to give it a command. Let's see if it's still, yep, it does. So VIFS is a remote file system command. So let me actually expand this out so it looks a little better. So this command is VIFS-server is one of my vSphere hosts. The username root is obvious, and the directory is my data store. So the command is directory dir, and the destination is the data store. So I can hit that, and it'll ask me for password, and it'll give me a directory. And if I wanted to know the directory of something, say xp1, I do it again, and it gives me that. So it's a remote file system tool. If I just type it in, actually VFS help --help, there's a ton of things that you can do. Let me scroll up just a little bit. There it is. You can copy files, give it a source and destination. You can specify your data center context and all that, your directory context, force for overwriting. You can get, which means you download a file. I can list all my data centers. I can list all my data stores. I can make a directory. I can move a file. Put is if I want to upload a file. There's a lot of stuff here that you can do. Let's see, I did one other. List data stores. Again, it's going to ask me for password, and it'll show all the data stores that that host.92 sees. So again, it's a useful way to do things remotely. You could also SSH into that vSphere host and do some of the commands there. But the point of this is with the VMA, it allows you to do things from a central place against all your servers, and you can do that here, but it just allows some file system commands and movement. Then you've got storage vMotion. Now, the thing about svMotion is there's a ton of options. So the way to cheat, unless you really need to just put this in one command line, is to do interactive. And then it's just going to say, okay, it'll walk you through all this stuff. So it'll say, you know, enter the vCenter service URL, as actually just wants the name or the IP address. So I'll just give it the IP. Username, you got to remember this is Windows. Connected, enter the name of the data center, and I believe that's Galaxy in my case. And the path of the virtual machine. So it's going to want to know this path. I'll give you a hint. There's an easy way to cheat on this. Well, maybe. Depends on if you've renamed any files. But I knew for a fact that this guy has his VM name doesn't match his VMX name. So I will paste that, except that's VMDK. So it's on data store 1, the directory is xp1, and his VMX, his config file, is xp.iometer.vmx. Hit enter, and it says enter the name of the destination data store. Now, here's the weird thing. That one, since it kind of wants it in a directory format, is in brackets. This one, it does not want in brackets. Every time I use this, it takes me 5 times to remember that. And this says, hey, you can move your disk independently of the actual VM or the VM config and all that. So would you like to individually place disks? You can say yes or no. I'll just say no. Go ahead and move them all. And it'll start doing a storage vMotion in the background. If we look, we should be able to see that. Cancel. And off it goes. Now, would I do that, or would I just come in here, right-click, and choose Migrate? I'm going to do this, especially in the VCAP exam. Time is of the essence. But if you do need to do this via command line, a bunch of them, script it, something like that, the svmotion command is there to use. So that's a quick walkthrough. We're going to go through ESX top later, vSCSI stats later, some of those tools that'll get you the performance information, but that's it for these. So let's jump back to the slide deck. Real quick on types of VMDKs, thin and thick. Build options are usually presented when creating the VMDKs. So here's the 3 types. I'm going to start at the bottom just because I think it's simplest. There's thin. It's, basically it creates the disk, but it doesn't allocate any of the space until it actually gets written to. So as data is written, that VMDK actually gets allocated on the back end. It's the fastest at creation time, but worst for first write performance. There is some overhead when you start to write new data because it has to zero it out and then write the data. And you can create that using all these you can create using the VI client or VMKFS tools. There's lazy zero thick, space is allocated, but zeroed out on the first write. So if you do a 100 gig VMDK, it actually allocates that space as being used, but it doesn't actually zero it out until the first write. Again, the idea is it makes the initial creation faster, but with reduced initial write performance. And then there's eager zeroed thick. All space is allocated and zeroed out, but it can take a while to create the disk. Now, we talked about VAAI, and the point of that is I can do eager zeroed thick and say, hey, Mr. Array, go zero this out and let me know when you're done. It may still take a couple of minutes, whereas with thin or lazy zeroed, it's a few seconds. But with VAI and eager zero thick, maybe a couple minutes instead of 20, 30, 40 minutes to do a really large zero. So it kind of depends on what your array can do and what you need. Now, we'll talk about this in a minute, but I want you to understand that thin is fine, but we're seeing more and more people do thin provisioning on arrays with thin provision LUNs. I'm not a fan of thin on thin. Not that there's a technical reason. There is some performance hit there. But I'm more concerned that people don't monitor their storage utilization well enough and they get themselves in some trouble. Also keep in mind things like fault tolerance that we'll talk about later, where you have a shadow VM and a full running copy of a second VM and instant failover requires eager zero thick. So some VMs will require that. You'll also often see that vendors will require that for some applications and some kind of virtual appliances. Usually it's less about a technical reason and more because they don't want you to thin provision and run out of space. But again, just understand the pros and cons. A little bit more mapping. So I just talked about this. If you're using thin provisioning, make sure you understand your full storage stack. Do you want to do thin provisioned VMDKs on thick provisioned disk, thick provisioned VMDKs on thin provisioned disk, or thin on thin? And I'm going to caution you against that. There's no right or wrong answer except maybe thin on thin, but it's more about who do you want to manage the risk of storage. If you say, I don't want any risk, or there's no such life as no risk, but I want the least risk, then you do thick on thick. But you're going to be allocating storage that you'll never use because nobody allocates servers with 95% of the storage capacity used. People always had a lot of buffer, so normally we see people do thin on one of those two. Just figure out where you want to do it. Be sure to utilize storage alarms and other metrics. So if you're using thin provisioning on your array, monitor that as well, but make sure you go into vCenter and you set your storage alarm so when you hit 80, 85, or 90% usage, you start getting alerted. VMware is going to tell you, and I'll kind of tell you that, they want 80% maximum, 20% free for things like snaps and other stuff. If you have a 50 terabyte LUN and data store, I'm not going to tell you to leave 10 terabyte free, but you definitely want to leave some, so adjust those alarm thresholds accordingly. You do not want to run a data store out of space. It's really bad at the array level. It's kind of bad at the VMware level. It's not as bad as it used to be. It used to be and normally we would see this because people would leave snapshots running, they'd fill up this data store, and it was just an absolute mess. Now you can kind of dig yourself out of that hole without having to have a whole bunch of free space on another data store, but it's still time consuming and it's risky, and it's not something you really want to spend all night at 3 in the morning trying to fix. So again, alarms are key, and make sure you don't run out of space. Monitoring disk statistics and latency. There's several ways to do this. We'll hit these definitely in detail in later lessons, but performance charts from vCenter are a big one. Easy to use, simple, predefined, no problem. ESX top. I see ESX top is more of a real-time tool. You can run it in what we call batch mode, store metrics, and look at them. But normally when I'm running ESX top, I'm sitting in front of the console looking at information. Same with vSCSI stats. I normally want to see some other information I'm not getting out of ESX top, but it's kind of real time. And then vCenter Operations Manager, which is a great performance tool from VMware. It's great because it figures out what is normal in your environment and will alert you when things are abnormal and help you pinpoint where the problems are. Important to watch these, especially if you start to tune queue numbers or change underlying storage. Make sure you gather information before and after. Looking at ESX tops and seeing latency numbers of 20 milliseconds for storage doesn't help unless you know that you're normally at 5 to 10. If you're 20 now, are you normally at 20 or is this new? If you don't know that, then it's kind of hard to make or just figure out what's causing an issue. So at least have an idea of what is normal and abnormal. Again, that's why I like vCenter Operations. It does that for you. But, not everybody wants to pay the license for it. And really, it's outside the scope for the VCAP. So just understand what we can do with the performance charts, the ESX top, and the vSCSI stats. Here's some information on configuring data store alarms. You go into vCenter and you configure these alarms just like any other, but you basically can create these on a per data store basis. And I suggest you do this especially for thin provision data stores, and start looking for things like utilization. That's normally what I do them on, and just have it alert you should you hit high utilization. Some simple storage performance troubleshooting we'll do again in more depth later, but start with the simple things. Check your data store latency. Hopefully you know what it is normally. Look for any commands terminated in the advanced performance chart. So go to your vCenter performance charts, go to the advanced. If you see commands terminated and it's not 0, you've got an issue. Normally it means something is very overloaded, and we need to start figuring out where that is. Latency is usually the biggest problem. You want your average under 20 millisecond. Try to keep your peaks under 30, though. I say that, I've seen VMware say that, but I routinely see peaks well above that. But when I say peaks, I mean peak. Sharp peaks and then right back down. If something's starting to hang around 30, you're going to start feeling the performance impact in your applications. And you can check these using ESX top. Again, we'll hit this more detail. With the device average per command, that's just going to tell you kind of what your average latency per command is. You really want that to sit around under 20. You definitely don't want it to hang around close to 30. Causes of high latency, it's pretty obvious. Too many requests for too few spindles. You're throwing a ton of requests. Read this, write that, let me know what this says, and the spindles are just having to back up and the queue gets too long. Here's another one. Sometimes workload changes. What worked fine with a set of spindles before, if the I/O got more random, they don't work as well. The disk heads are flying all over the place, and you just don't get the same number of IOPS doing random I/O as you do sequential I/O. So you may want to do something like vSCSI stats and check that out. Or new jobs such as backup. You've added new things that were not part of the original workload, and now it's causing an impact. Simple, but very common. So that's it for this lesson. We'll continue on with this in the next one, and I look forward to seeing you there.